me, I learned a lot on the last blacklist. All right.
Is that, question, is there someone that doesn't know Bill? No.
Yeah. I've cut back. Steve's the top poster now, so you guys can rip him. All right, today we're going to talk about encryption. Encryption is one of those things I thought I always kind of had a somewhat okay handle on. And for this talk, I started doing a lot more reading about encryption. And I'm using encryption loosely. We're going to be talking about cryptography in general today, and then and specifically about lasso and how it applies to lasso. And the thing that I realized as I was preparing this presentation is that I really don't know anything about cryptography. So I just want to point that out. I'm not a cryptographer, and my understanding is very rudimentary. And if you have an application that relies on cryptography, or if it's a high-value application, something that deals with a lot of money or financial transactions, you should really hire someone who actually knows about it. So I just want to set the bar. My understanding is pretty low, and you may ask questions I might not know the answers to, or I may give you your own answers. All right, encryption. Yeah, like I said, the thing about encryption is that it seems on the surface to be really easy to understand, right? You have some text, you pass it through this function, and out comes some garbled stuff. And to me, the layman, it looks encrypted. The thing about encryption, though, is there's a lot of nuances, and if you don't get every single one of them correct, then what comes out may not be all that secure to someone who knows what they're doing. So the thing to know is that with encryption, you're going to want to make the right choices, and we'll get into how you do that in a minute. But and then I also want to point out that when you don't get it right, or if you have a breach, you got to swap out all your secret passwords and keys. So it's important. We'll get into that too. It's important to have a method by which you can rotate your keys. All right. We talked about this a little bit yesterday. Everything when we talk about now, it comes from people who know what they're talking about. So, which isn't me, but you'll have to forgive me. Don't ever create your own cipher. Don't create something that will obscure something that you think will encrypt, because most likely it won't work. I mean, some of the brightest minds have created some encryption, and it's been broken by other bright minds. So it's a dangerous road to go down. And there's actually a few examples where big companies thought that they were being tricky and they were obscuring things, but they weren't encrypting them. And the effort to obscure is probably more than the effort to encrypt. So you might as well just be safe and use encryption. The experts also recommend you not use low-level APIs like OpenSSL, which is how Lasso is encryption's based. So because with the low-level APIs, there's a lot of options, and those options aren't necessarily expressed for Lasso, so I don't know exactly what Lasso is choosing for us. But if it's not choosing exactly what should be chosen, and we'll get into that in a second, then you're going to end up with some weak encryption. And the thing to remember is that there's no real way to test for it. You can't run a program that will test your encryption to see if it's strong or not. The only way you can really strongly test it is to hire someone. It's very, very expensive to do so, to try and break it. And even then, even if they don't break it, doesn't mean that someone more determined, especially if you have a high-value application, won't break it. So what they do recommend is that you use a high-level API, something that has already chosen all the safe defaults, all the nuances that you need for the application. There's actually 3 that I know of that are recommended. One is Keyzar. That one is provided by Google. It comes out of Google, and it has a few hooks. One's for Java and one's for C, and I believe there's a few others like Python. And then the other 2 are GNU-PG and then the Cryptlib. And the thing for me is that I'm going to, down the road, once Lasso 9 is stabilized a bit, I'm going to be looking to port one of those, I haven't decided yet which, to Lasso so that it will be available to us. For free to jump in and ask questions as I move along. All right, so why would you want to use a high-level API? Simply because it is just like the same reason you use any high-level API, right? It abstracts all the technical details that we can trip up on and make wrong choices. So it will instead pick safe defaults that you should be using. It'll pick the algorithms you should be doing. It'll pick the block modes that you should be using. That way you don't have to think, okay, should I use MD5 or RIPE MD160? You don't have to make those choices. It's more just, I want to encrypt this, I want to decrypt this, and here's the password. It makes it that easy. These APIs also have built-in features for rotating the keys, which again are really important when you have a breach. Also when the algorithm becomes outdated because it's been broken, like MD5, or when you need a larger key size because computers are just that much faster, you know, year after year, you're going to need some way, at some point, your application, unless it's going to be only a 6 month or a 1 year thing for you, eventually in the future, at some point, guaranteed you're going to have to choose stronger encryption or more bits or a stronger key, and you're going to need to be able to rotate it. So these APIs make it easy to do that. Otherwise, there's a lot of work for you as the developer. They also keep track of the version. So there's two approaches to storing. When you have pre-existing data that's already encrypted, there's two approaches really to when you rotate out keys and you upgrade your algorithms. One is you just simply record the version that's stored in the database and you leave it alone. So if it's been stored with an MD5 hash, you just leave it alone and it stays MD5, and then any new data goes in as with the new hash or a new encryption algorithm. The other option is you, for the case where you can actually decrypt it, you can go ahead and decrypt all the data and then re-import it under the new encryption. So it just kind of depends on your application and what you're trying to do. For hashes, we'll get into that. It's one way, you can't decrypt it, so you won't be able to upgrade this. So in that case, version is really important. Otherwise, you'll have to ask your users to sign in under the old one and then have a new table for them to record their new password, and it's kind of a hassle. All right, so now we're going to talk about where those nuances will trip you up. The random number generators in general, the default ones that are on most operating systems, are not suited for encryption. So it's not random enough. It doesn't have, it doesn't have enough entropy to make the encryption strong. So I have up there a few things that have been recommended of what you should be using. But really what we should be using is this high-level API that already makes all these choices. So if the encryption is using some default random number generator, already it's weak and it can be broken.